Hey guys, what's going on? Welcome back to the Your Forest podcast. Thanks for listening. This is episode 10. Today, I'm really excited about this podcast. I have a man named Dalibor Houdek on today. He works for FP Innovations, which is a non-for-profit organization in Alberta, or I guess in Canada. They do all kinds of research into different wood technologies and strategies that'll help the forest industry move forward and be more sustainable and more efficient and all that kind of stuff. So Dalibor, his background, he has a PhD in technology of wood processing. And he came in, he brought in his box of samples, and he's got samples, kind of a show and tell thing is what he calls it. And we sat down and talked about kind of a lot of the things that FPI is working on. And there's a lot of cool stuff, a lot of cool technologies as far as different wood processing technologies, different ways to use wood fiber and lignin and cellulose and all kinds of stuff. We get right into it. So, check this one out. Yeah, it's going to be a good one. This podcast was brought to you by Greenlink Forestry. Greenlink has been providing quality resource inventory services for over 15 years. If you want the best, go with Greenlink. I just made that up, but it's true. So do it. Anyways, let's jump right into this podcast and we'll start talking about wood technology and stuff. You guys are really going to like it. It's an awesome podcast. Dalibor really knows his stuff. Here's Dalibor and me. Maybe you just want to explain your background a little bit and how you got to be where you are today.
Oh, that's going to be a long story.
Okay, well, maybe we'll shut it down real quick.
No, so I started studying furniture manufacturing and design.
Okay.
And from there, I went to University of Forestry and Wood Technology in Zvolen, Slovakia.
Okay.
And I got fascinated with big pieces of wood that were joined together like furniture.
Okay, yeah.
And so that led me to wood construction and timber engineering. And after a stint in the private business, I had my own log building and timber frame building company.
Oh, nice.
Life took me to Canada.
Yeah.
And I ended up at a company called Houdek, which was a predecessor of FP Innovations. So actually, this is my first job in Canada that I've had for the last 17 years.
Nice. Right on. That's awesome. Loyal.
Yes. It's a fun place. So, there's always something new. So it's pretty easy to stay interested.
Yeah. Well, like all the stuff that you showed me here before the podcast started up, like he's got a whole box of all kinds of gadgets and little examples of what you guys are working on. And it's pretty neat. I wish I could, maybe I'll take a picture of that afterwards.
Sure, you bet.
And we'll post it up or something. Yeah. If you don't mind.
No, I don't mind.
Awesome.
No.
Cool.
So what's our show and tell? So
yeah, exactly. Yeah. Yeah. That's perfect. So what's your position now with FP Innovations?
Well, I'm a provincial leader for Alberta.
Sounds pretty important.
Yeah, I don't know. I know it's not. It's just kind of equivalent of a regional manager. So I look after our activities in the province. Look after member relations, government relations, and making sure that our projects are done on time and on budget.
Gotcha. So I imagine you're kind of falling away from what you love, which is probably the more technology side of it a little bit.
Technology
more the management side of it.
Yeah, you bet. You bet. But that's what happens.
Yeah, that's the way.
I started my log building company. I started building log homes, and before I knew it, I was selling them and managing production, and that's just how it works.
Oh, that's the way it works for everybody. Yeah, that's good. But you still get to do this kind of stuff. So I appreciate you coming in. This is awesome.
Thank you.
I'm really excited.
Thanks for having me.
Yeah, that's cool. So I'm trying to think of how we want to start this. Like I had a few things in mind, but the stuff you brought in, let's just talk about some of the stuff that you brought in. Maybe what some of the new things, because people, I think when they first think about forest products, right, the first thing they think about is just lumber or plywood or OSB. And they just think of, I can build stuff with it, or I can make paper or toilet paper or newspaper or cardboard. But I think like you guys have so much more going on. Like, you're separating lignin and cellulose and you're doing specific things with that and engineering them in specific ways for specific properties. Like, it's extremely interesting. It's not anything that even myself as a forester, I haven't seen it before, heard about it, right? But I don't know anything about it.
Right.
So maybe we'll just start with something easy and we'll work our way through your box, I guess.
I guess. The traditional forestry and the traditional products like lumber,
Yeah.
actually in many ways is a platform technology.
Of course.
It's a platform material. You use it as a building block of building a house, or you use it as a raw material for some other products.
Yeah.
And one of the ones that actually is close to my heart and my background is all these building products like cross-laminated timber and glue lam.
Right.
So cross-laminated timber, for those that don't know what it is,
I think most people probably don't know.
It's really like plywood on steroids.
Okay.
So imagine 2x6 boards that are glued together in perpendicular fashion like a plywood would be.
Right.
And it could be anywhere from 3 to 9 layers thick.
Yeah.
So you can create these massive panels that would be 3 meters wide, 10 feet roughly.
Okay.
And maybe 40 feet long.
Yeah, must take a big machine.
It takes a big machine, and it takes a crane to move it. But once you glue it all up, suddenly you've got a big piece of mass.
Right.
And we call it massive timber.
Okay. Yeah.
And it truly is.
What it is.
It truly is a massive timber.
Yeah.
And you can start using that to build some pretty incredible buildings.
Yeah. No, I imagine.
And I'm not sure if you've heard, but just recently there was a 18-story CLT/glulam building built in Vancouver.
Yeah, I did hear something about that. We were talking about, mentioned it or something, but yeah, go ahead. Sorry.
Yeah, no. So I mean, it's an incredible material.
Yeah.
That
and it was made out of that.
It's made out of that.
Oh, okay.
Yeah, it's made out of CLT and glulam.
Okay.
And just an interesting fact. If you notice how concrete buildings are done, let's say downtown Edmonton.
Right.
It's a one story at a time.
Yeah.
Stacking it up, you crib it, you pour it, there's concrete there for weeks and weeks and weeks, and they keep just slowly pouring. Once you pour the concrete, you have to wait for the concrete to set before you can start building,
right.
Building more stories on top of it.
Some inefficiencies, a lot of time off. Yeah.
Right.
Yeah.
And I mean, that's just the way that the process works.
Yeah.
Well, with CLT, this 18-story building was erected in 9 weeks. They were doing 2 stories a week.
Yeah.
Because there's no curing, there's no...
Just keep going.
It's just prefabricated in the factory. They bring it on the truck.
That's pretty amazing.
And you're starting lifting these panels together. They're jointed, they're connected, and off it goes.
Yeah, that's wild. Like so what are the... I don't know if you know the answers to this, but as far as structural stability for like say you had an 18-story concrete building that was built well, and this woods building that was built well, structurally, like, are they going to sway kind of the same with the wind? Are they going to have the same... like, I don't know, properties in that sense, or?
Well, let's put it this way: they all things being equal, they will both meet the building code.
Right.
They will be equally safe. In fact, I think that the wooden one will be safer.
Right.
And I know it will be safer.
Yeah.
Particularly in some catastrophic events like earthquakes.
Right.
So if you think about where this 18-story building, and it's the tallest wooden building at the moment in the world.
It is, yeah. That's cool.
For a while, there's another one that's going to be coming up soon, but
there's always somebody who wants to beat you out
for the time being. And Vancouver is seismically quite active.
Right, of course, right on a fault line, isn't it?
That's right, yeah. And so it has to be designed for earthquake resistance, and there's no better building you would want to be in an earthquake than a wooden building, because it will sway, it will move from side to side, but it doesn't collapse.
I imagine even torsion wise, like they probably twist a little bit more than a concrete building would, or something like that. So, yeah.
I mean, try to just imagine having a thin plank of concrete. Right. And you try to flex it.
Yeah.
It'll crack.
Yeah, for sure.
Right?
Yeah.
Wood will bend and just come back.
Yeah.
Right? Bend and come back. And you could use it. I mean, they didn't make bows out of wood for nothing.
Yeah, exactly.
You can flex it, release it, and it will work forever, right?
Yeah, you're speaking to my heart right now. So I love archery.
Yeah, there you go. There you go. Me too.
Awesome. Yeah, no, it's pretty fascinating. The first time I heard that, I was like 18 stories, and I think people don't really, you think about 18 stories, you're like, okay, cool, 18 stories, and then you see it, like I see pictures of it. If you Google it, it's pretty fascinating. That
It is.
Yeah, it's cool.
You know, I'll tell you a little story. I was reminded myself of that last week when I was in Jasper at the AFPA conference.
Yeah.
Several years ago, I was doing a presentation for engineers and architects in Taiwan.
Oh, okay.
And I was telling them about this push for taller buildings, and he says, you know, we're gonna have 20-story buildings, and we're gonna be building this out of wood, and we left this conference center, and it was a 20-story building, and right. The guy that I was with, he just kind of looked up and he says, would you build this out of wood? He says, this is 20 stories, and I looked and I go, wow. Yeah, this is a big building. Yeah. So I had a very short what do you call it?
Education or
no, it was more like I was testing my faith.
Right.
I was like looking at it. This is a big building.
That's I know for sure.
But you know, I trust science and I trust engineering. I said, well, we can do it, and actually I think that we'll probably see 30-story and even 40-story buildings in the future.
Oh, I'm sure the technology only double, or only, what is it? What's the law? The name of the law there? Not Moore's law. Is it Moore's law? I forget. Technology doubles every 3 years or something like that. I forget the name of the law, but yeah, it's something like that, right? You know, I imagine it applies to wood technology as well.
I think so too, and I think, you know, when I was actually doing this presentation in Taiwan, I was trying to compare historical buildings and new buildings and nature. And when you look at the tallest trees,
oh yeah,
the redwoods,
yeah,
they're in the 40-story height.
It's pretty ridiculous.
And yes, and actually interestingly enough, at around that time, there was a project that was conducted by, and I forget this name of this engineering company. Mm-hmm. They designed skyscrapers. Okay. Pretty famous engineering company.
Okay.
And they were doing a calculation how far wood could go. Mm-hmm. And I think that how tall wooden buildings would actually, you know, be feasible, right?
Gotcha. Before they're compromised. Okay.
Yeah, before they're too tall.
Right.
And I think that they came up with around 40 stories. And I go, okay, Mother Nature made trees that are about 40 stories, didn't go any further. I think that's a pretty good guess.
That's probably
there must be a reason, right?
Why do you need a taller building than that anyways, I guess, right? Like, no, 40 stories is plenty. I think the tallest building in Edmonton right now is something like that.
Yeah, I don't think it's 40. Yeah,
no, I don't think it's not. Yeah.
No, I don't think so. I think that we're building now the 70-story or something.
Oh, that's right. That's right.
Which will be tallest west of Toronto.
That's ridiculous.
But you know, if you get 30 stories, you could build 95% of buildings in Canada.
Meanwhile, someone from New York is listening right now, laughing.
Right.
40 stories.
Or Shanghai.
Yeah, or Shanghai. Yeah. Or Saudi Arabia. Unlikely, but So we were talking about the CLT, and the glue lam. And then, let's take a look at the...
Well, we can talk about... I mean, we can stick with the buildings.
For sure.
And, let's start talking about energy.
Absolutely, yeah.
Right? So, energy is... buildings are a big consumer of energy, whether it's through construction or utilization. Some studies say that 40% of world's energy is consumed by buildings, either building, demolishing, or operating.
Oh, really? So not the actual like day-to-day functioning, but the construction.
It's everything combined.
All combined. Okay.
All combined.
Okay.
Yeah. So energy efficiency is important.
Yeah.
And we're also looking at obviously the environmental sustainability and the whole idea of environmental footprint.
Right.
And so wood actually has a beautiful combination of R value, you know, the energy insulating properties, with mass that gives it also a capacity to store heat.
Right.
So when the temperature fluctuates, it kind of equalizes the room temperature.
The difference.
Just like if you have a big fireplace in the house and it gets all warmed up, even then when the fire goes out, it's still warm and still radiates.
It's radiating back. So
So
whereas
the
concrete
wood
or something would probably just consume that energy and Yeah.
If it's insulated from the exterior, it would act very similarly.
Right.
But only from the perspective of actually accumulation.
Oh, okay.
Not on an insulation properties.
Gotcha. Right.
But wood's got kind of both, and it's a lot more insulating than concrete or steel or aluminum.
Right.
But it's got a lot less mass.
Right.
So it's kind of a compromise. It's in between.
Right.
And obviously, the more air pockets there is in the wood, the better insulator it is.
Right.
So cedar would insulate a lot better than oak, for
Gotcha.
example. And so some of these new materials are actually playing on this. What I'm holding in hand is a sample of fiber insulation that's we call a multifunctional panel. It's a product that is I would probably best describe as very low density MDF.
Right.
That's overlaid with two 1/4 inch sheets of OSB.
Right.
And it provides an extra insulation as well as structural properties to buildings. So if you were to use this on exterior of a framed home,
right,
it would take place of the sheathing that you would sheathe the home with, plus your
fiberglass,
rigid insulation.
Right.
Not necessarily fiberglass, but your styrofoam, for example, that EPS that you would use around the building to
Gotcha.
Counteract the effect of thermal bridging in the building and add extra insulation to the fiberglass that's between the studs.
Cool. I just want to explain real quick, just for people who might not know MDF and OSB. So OSB, I mean, there's a lot of forest professionals listening, but there's some public listening as well.
Okay.
So OSB is basically chunks of wood, larger chunks of wood, maybe an inch or 2 or 3.
Yeah, wafers.
Yeah, they're wafers. They're small slivers basically of wood, and they're all pressed together with some adhesive, and it creates a board. So that's what most people's homes are made out of, right? It's not plywood;
correct.
it's mostly
That's
OSB.
correct.
And then the MDF is how would you?
It's a medium density fiber board. That's what it stands for.
Right.
So it's basically you take a tree, you break it into individual fibers,
right,
which are fairly.
They're very, very small. Yeah. So individual cellulose fibers or whatever they just look like, for people who don't know, they just looks like a small piece of hair.
They're even smaller than hair, maybe a millimeter long.
Yeah.
And they're combined into mats with some resin as well, and it's pressed.
Right.
And it creates this product. A lot of kitchens. Kitchen doors in particular are made of MDF,
right?
Because you can mold them and you can paint them. So if you've got a kitchen that's not made out of solid wood and that's got paint on it, most likely the doors are made out of MDF.
Right. Yeah, it's lighter too. Yeah. And even lots of cabinets and stuff.
Cabinets. Yeah.
Right on. So that's
So that's one thing. Another thing, if you've got pulp, it's really just a fluff.
Yeah.
And
so pulp is the in between stage between wood and paper.
That's correct.
Who don't
yes.
know. Yeah.
And so you could also form it into these insulating materials, into these boards that are very light and have very high thermal insulating properties.
Yeah.
That could be used in construction. So it's it kind of took us from traditional lumber and pulp into some applications for construction industry that are very exciting.
Yeah, no, there's so many different things that we can do with it now, and that's still just at the raw wood fiber perspective. We're not even separating it into lignin and cellulose and other things yet. So there's so much further you can go yet, and this is just the tip of the iceberg, right?
That's right.
So the wood technologies, it's fascinating what we figured out now, right? It's pretty crazy.
Right.
Yeah. So what else you got there?
I just pulled out this sample that represents a bridge.
Okay.
And that's potentially another application for this cross-laminated timber.
Oh, okay.
This plywood on steroids.
Yeah.
And not everything has to be made out of wood.
Pull this mic. Just angle it up towards you a little bit.
Okay.
There you go. Yeah. Perfect. Yeah. All of a sudden, I see the spikes going a lot bigger.
So not everything has to be made out of wood, but you can combine steel or concrete with wood in applications where you actually take best advantage of it.
Gotcha.
So as I was talking about how you construct these tall buildings
Mm-hmm.
with cribbing and pouring concrete, the same happens with bridges.
Okay.
So, you could bring in steel girders,
Right.
and as soon as you set them in place, you could bring these massive wood panels that will be laid on top of it to create a surface, the bridge deck.
Right.
Right.
Yeah.
And that's it. And you start waterproofing it, then you put
you're good to go.
your surface on top of it, and
So it's interesting that it has that much. But it's not laid. Yeah, it's not laid flat like a piece of plywood. It's laid
flat.
right, but the orientation of the boards are vertical on the bridge. No,
they're flat. It's all flat. Yes, it's all flat. So
like it would just be just like the veneer is actually
it's just like a veneer.
It's just flat on, like, so you'd be driving on the surface of it, not on the edge of the veneer.
That's correct.
Really?
Yes.
Oh, okay.
Yes.
Interesting.
Yeah. So it'll be like this. It'll be flat like that.
Oh, okay.
So
interesting. I would have thought for whatever reason that it would be the opposite way, just out of, you would think that the strength would be better having the grain going the opposite way, right?
Right.
But not necessarily.
No, the strength is provided by gluing these boards together.
Okay.
You're creating this depth of the panel.
Gotcha.
So the deeper the panel, the more strength there would be.
Okay.
So if you go from 3 layers to 9 layers,
Of course, yeah. It's gonna be
massive,
strong. Right.
Massive addition of strength.
Okay. Cool. That's awesome. So has that been used to date?
It is being tried. It has been used on a number of bridges in eastern Canada.
Okay.
We're working on perfecting the system and doing some more trials.
Right.
The word innovation, everybody has a little bit of a different perception of what that means, but most often for something to actually become a thing, you need to do it more than once.
Yeah.
And one of the things that we see quite often is there's a lot of one-offs. The first one in the world. If there is no second one and third one and fourth one and 50th one, it's really not a thing yet.
No, it's the same thing with scientific studies, right? People see research studies that come out and they go, this research study found X. It's like, that's great. Has it been vetted? Because science is only good if it's been vetted by 50 other people who come to the same conclusion, unbiased, right? So it's, If you can take it and replicate it every single time and it gives the same result, it's true. Now it's a proven thing,
It's a proven fact. And so even though it's been used on several bridges, it needs to be proven in different jurisdictions,
right?
Because every Ministry of Transportation will have different rules about building bridges. You got to convince the engineers, got to convince the people that build these bridges that they're going to last. So there's lots of things
it's a good product.
there's lots of things that need to fall in place for something to actually become a standard thing. Of
course. So like with some of these engineered timbers and pieces like engineered lumber and stuff, do you think that places like the coast where there's like a higher humidity level in that, do you think that would have a role in its application? Like whether or not, like say here in Alberta where it's a little bit drier, it would kind of keep its form better, and like whereas out east or out west or whatever, maybe it might swell and lose some of its, or is that, do you think that's probably not quite the case?
It really depends on the application. If we're talking about bridges, whether they're in Alberta or the coast, the wood would have to be protected. So you have to waterproof it one way or the other. Right. And once you waterproof it,
that's irrelevant.
It should really be irrelevant.
Yeah.
There's wood that's exposed to air everywhere, whether you go to Asia or Canada. And the wood generally lasts hundreds or thousands of years, as long as it's kept dry. Yeah. And the sways in the relative humidity
shouldn't make a difference.
Not that big.
So, as long as you seal it off, then you're good to go. Yeah. Oh, cool. Yeah, because I would think that some people might have that reservation with, like, building homes or something like that, right? Like, oh, I want to use plywood instead of OSB. Maybe it less chance of it swelling or less chance of it, but I'm not really sure about the application of that. But yeah,
Right.
It's just something I thought about because I've seen, you know what I mean?
Right.
You see an old piece of OSB that's all swollen up and got bubbles in it and stuff, and it's kind of like, ooh, that doesn't look too good. But yeah.
The bottom line is when your water is getting onto your sheathing, you've got another problem.
You got a problem. No matter what
it doesn't matter what
right?
it is.
Just keep it off. Yeah,
yeah,
of
you
course.
need to keep it off. So
yeah, that makes sense.
Looking at making sure that buildings are well kept and that the water is not getting where it's not supposed to is important.
It's a good rule in life in general. Just
That's
make sure
right.
the water doesn't go where it's not supposed to.
That's right. That's right.
Many applications.
Yes.
Awesome. That's cool. No, it's interesting to see. How long do you think till like some of these things make it to market? Still, I mean, a lot of them obviously are still in the testing stages and stuff, but some of it's being used. You said, right? Like for example, we have the LVL mill down south in Alberta here,
That's
that's been in operation for a long time.
A long time, yeah. We've got a glue lamp plant that's been in operation for decades.
Right.
I think they just celebrated 60 years.
60 years,
I believe, yeah.
That's pretty
Western
cool.
Art Group, yeah.
Yeah, and it's mostly for. What's the application of, not obviously, but the main application for glue lam?
It would be construction.
Just construction in general, like for.
You would use it for if you drive around Edmonton and you see these new LRT stations.
Oh yeah.
A lot of them will have glue lam beams and some glue lam deck on them.
Yeah.
So that's glue lam.
Yeah.
If you go into some swimming pools. Hockey arenas. If you go into
hockey arenas, a lot of LVL, I think.
The two and lots of glue lam too. All these arches in the arenas probably came from Western Art Group.
Right. There's lots of people that you don't like. I think you sit in an arena and you look at like a small town arena type thing. You see you got 80 meters of one solid piece of wood, but you know what I mean. And you're like, we're not cutting down 80-meter trees and making them. That's all engineered.
That's all engineered, and that's most likely all glue lam.
Yeah, that makes sense.
And also from industrial perspective, for example, potash storage.
Okay.
In Saskatchewan,
right?
A lot of these potash storage facilities are made of wood because wood doesn't corrode.
Right.
You can make it out of steel and put some salt on it, and before you know, everything is rusty.
Right.
Where wood doesn't rust, it doesn't matter. Salt doesn't matter to it.
Yeah. Oh, that's cool. Interesting. Yeah. No, there's so many applications for this stuff.
Oh yeah, and it's just wood is just so fascinating.
Yeah. Maybe we'll get into some of the like the lignin and
you bet.
The cellulose
you
stuff.
Bet. You bet.
So he has a tin or a little plastic. Container, I guess. Yeah, and I thought it was just a solid mass, but it's all powder stuffed in there, and it's all. You said that's all lignin, right?
It's all lignin, yes.
It's a light brown color.
So
maybe we'll explain what lignin is first, I guess.
Yeah. So when you look at wood from chemical perspective, there's three main components. There's cellulose, there's hemicellulose, and lignin.
Okay.
If you want to have a comparison, it would be kind of like reinforced concrete.
Okay.
So you've got these steel rods in the reinforced concrete, and that's your cellulose. That's very strong.
It's the fiber.
And then you've got the concrete in between them that binds them all together, and that's lignin.
Okay.
Hemicellulose is just there, down here. So it's actually lignin is, I believe, and don't quote me on this 100%, but I think is the second most abundant natural compound on Earth.
Next to
cellulose.
Yeah. Okay. So there's more cellulose than lignin.
Yes.
Okay.
Yes.
Gotcha. Okay. Oh, that's pretty crazy.
So trees would have them. Other plants would have them.
Yeah.
Agricultural crops would have them.
Right.
Those are basic building blocks of fibrous materials.
Right. So plants.
So all fiber
and all that stuff. Yeah. It's all. Yeah. Interesting.
So once you start breaking the trees or wood apart into the cellulose and lignin, obviously you've got pulp that we use for papers and all kinds of other applications.
Right.
Beyond paper.
Which a pulp would be mostly cellulose, right? Like
right. That's right. But they do extract lignin as well.
Right. Okay.
Because they have to break it apart.
Yeah.
Right? But now they're starting to actually find applications for lignin. First, there was for many, many years, there was a joke that no longer exists. And it went something like, you can make anything out of lignin except money.
Yeah.
It is a wonderful material. It's got many applications, but as I said, it's no longer true.
Yeah.
We have actually the first commercial scale demonstration plant for lignin extraction in Alberta.
Oh, really?
In Hinton.
Oh, nice. Okay. I didn't know that.
At West Fraser Mill.
Yeah.
And it's actually the world is going to Hinton to see it.
Check it out.
It's really remarkable, and it is our technology. It's FP Innovations technology.
Nice.
And so what we use it for is we use it for many applications in composites and plastics, but more importantly in resins.
Okay. Yeah.
And so it actually ends up being a direct replacement for phenol resorcinol resin that comes from petrochemical.
Really? Okay.
We're at about 20% replacement.
So
rate.
So what exactly does that mean?
But basically what it means is when you're making glues, when you're making resins to make plywood, for example, it's phenol resorcinol glue.
Okay.
And you need the resin to make the glue.
Right, of course.
And that comes from petrochemical
And so now
process.
you can replace it with...
Now you can actually take lignin and you just do 20% of lignin plus the petrochemical.
Right.
And there's no other process you need to do with it. You just use similar chemistry or same chemistry. There's no... It's a direct drop in.
Right. Just throw it in. It does. It works.
And take out the 20% of the petrochemical and put this one in.
Huh.
We're obviously working on higher levels of replacement.
Right. But to start 20% is huge. Like that's got to be a pretty big cost efficiency, right? Like it's.
I would say if I recall it correctly, for an average plywood mill. Mm-hmm. It's probably $500,000 a year savings on glue.
For forestry, that's pretty good.
Just for
save
20%.
$500,000, they'll be happy campers.
Yeah. So it's a major cost in the plywood mill for resin.
Big time. Yeah.
And now the same applications would go for the oriented strand board that we were talking about before.
Right.
You could use it for MDF that we mentioned, the medium density fiberboard that we used for insulation.
Yeah.
So there's other applications for this resin, and I think that as we move to higher levels of replacement of petrochemical resins, it'll get even more exciting, and the cost will go down even further.
Well, yeah, and like the sustainability of it too, right? Like so, I talked lots on this podcast about how wood fiber and just trees in general are one of the only truly sustainable building resources we have on the planet, right?
Right.
They basically grow themselves in Canada.
That's right.
Right. Like
that's right.
Yeah. You don't have to add any kind of nitrogen or any fertilizers but it's so to have something where you don't have to maybe mine for whatever petrochemicals you need, you can just take it from the trees. Mm-hmm. That's going to grow itself back anyways in a matter of 60 years or 80 years. Then why wouldn't you do that? Right.
That's right.
It's much more sustainable.
That's right.
You're not pulling carbon from the depths of the earth and bringing it to the surface. You're just keeping the carbon that's already in the cycle.
That's right.
Yeah. So the sustainability aspect of it is like that's a massive bonus for sure.
Right.
Yeah.
So imagine that you dissolve the lignin from the tree and you use it to glue wood together.
Yeah, no, that's
just
it's kind of funny.
Just kind of makes sense, right?
Yeah, I'm gluing wood with wood, no big deal. Yeah, it's interesting to see that like the forest industry might become like self-sustainable in its actual inputs that it requires, right? In that sense, with something like lignin. So do you think? I know this is a bit out to lunch question maybe, but do you think there's a potential for there to be one day maybe like a higher percentage or maybe like 100% use of lignin as the resin? Or
that's the goal.
That's the goal, right?
That's the goal.
So working towards that.
Yeah, that's the goal.
Nice. That'd be fascinating to find out. Yeah.
Yeah.
So how you think it's a ways off yet though? So it's
I think and I'm not a chemist, so I'm gonna try not to get in trouble. But
nobody outside listening is either, so you don't have to worry about too much.
It has a different reactivity, so you need either longer curing times or higher temperatures.
Gotcha. Okay.
And so I think to go to 100% replacement, I think you'd have to facilitate some higher reactivity of the whole resin.
So you'd probably need different kilns and stuff to do it properly.
Maybe, or you need to add something else to it so that it cures faster at lower temperatures.
So maybe never 100%, but the more you can get, the better.
That's right.
So
that's right.
20% is a huge step.
That's right.
Like, that's awesome as it is.
That's
to
right.
see that happening.
That's right.
Yeah, we're gonna be proud of that.
Yes,
for sure.
Absolutely. And it comes out of lignin that comes from Hinton.
Yeah, that's wild. That's in Hinton, actually. I didn't know they were doing that.
Yeah.
So what's maybe just briefly, like, I don't know if you know you said you're not a chemist, but it's a chemical process to remove the cellulose and the lignin from each other.
It generally is, yes.
Kind of like the pulp process.
Yes,
I guess.
it's like a pulp process.
Yeah.
Pulp mill really, right now, and I guess it always has been. It has been a biorefinery.
Right.
Where wood is one of the raw materials as a resource.
Right.
So even though most pulp mills are still making majority of their dollars through traditional products, there's more and more that's coming on stream in form of lignin, cellulosic nanocrystals that you probably are going to ask me about a little later.
Yeah, it's coming.
These different sugar streams,
right?
Refining into some what was I gonna say?
Not sure.
Other platform chemicals.
Yeah, of course.
For other applications. So it's really a biorefinery already, and obviously they're creating a huge amount of bioenergy.
Yeah, the bioenergy one is a huge one. I had. I don't know if you listened to. I had a guy on, Chris Olson. He was starting his own company, or started his own company for creating. Oh man, I'm having a brain fart. Biochar.
Okay. Yes.
Yeah. So he was talking about some of the biofuel he can create from the biochar, from the pyrolysis process and stuff like that. So that's one type of new I guess wood technology that I've already gone in depth to. I'm doing so much research all the time. I forget about most of what he said, but it's an interesting podcast. I have to listen to it again myself, because when I'm doing these podcasts, a lot of times I find myself engrossed and I'm thinking about the next question and stuff.
Right. I understand.
And then that was one thing I did have written down was creating energy from biomass. Right. So I had the biochar way where I know there was one way. I don't know if you know anything about this, but it was something I saw recently on the internet. There's some kind of, algae process where they have algae consuming cellulose, and I still don't understand how the hell they're making fuel out of it, but apparently it's can directly replace petrochemicals at some point, petroleum and stuff like that. So I don't know if you know anything about that.
Yeah, I'm not sure. I'm not sure anything about the algae.
Yeah,
I know there's a process, or there's companies and organizations we work with. On converting biomass into biofuels directly. One that's probably the largest and most covered, I guess, in press is the biorefinery in Latuque in Quebec.
Okay. Yep.
And they're going to be they're working towards converting biomass into diesel.
Right. To biodiesel. Okay.
Yes. And there's, as I said, lots of processes where you take biomass and convert it into sugars.
Right.
And then the sugars are converted into other platform chemicals. And then you use those other platforms to create other materials.
Yeah, you just keep breaking it down.
Keep breaking it down until you get something that you can actually make into composites and plastics, and
you get the building blocks of life, and you can do all kinds of stuff with them.
That's right.
Yeah, that's awesome. Yeah, the biofuel thing, because I know there was a big stint when I was in university. They were talking about creating biofuel from corn and that, right? And of course, again, the problem with building biofuels with corn is it's an agricultural product. It's not sustainable.
It's food.
It's food, right? And there's a lot more. Yeah, it's just it's going to consume a lot.
Right.
Whereas we can do it from something where we have like, I don't know how many millions of pounds of sawdust every year that goes, we try to use up as much as we can, but a lot of it goes unused, I'm sure.
Right.
And like, why not take that? And it's already available and there's lots of it.
Yes. And, you know, I think that you'd be surprised how little of wood gets actually wasted.
Yeah.
Particularly in industrial applications. If you're a sawmill and if you can't sell your chips and your sawdust, probably not going to be in business for very long.
Yeah, that's true. They're
so
pretty efficient
everything
already.
everything has a stream, everything has a home.
Yeah.
And even if the sawdust is converted into or shavings into animal bedding, it has an application.
It's still something.
It's still something, and it has a value, and it's got a price.
It's not sitting around rotting.
That's right.
Yeah, exactly.
That's right. So it's either bioenergy, or it could be converted into wood pellets.
Right. The wood pellets one, that's probably a big one, I guess. Yeah. They're starting up a wood pellet. Or do they have it already in Drayton Valley, or are they just starting it up?
They're starting it up. I think they're building. I think it's kind of halfway through. I think.
Okay.
And Whistle, I think that they're doing.
Yeah, it'll be interesting to see how much they can take in, right, and what their margins are, kind of. Because I guess that's the next step, right? Is just taking those secondary products like the chips and sawdust and that, and just increasing the margins and what you can do with it and the efficiencies and the sustainability of it all, right? Mm-hmm. So it just keeps getting better, right?
Right.
Yeah.
Right.
No, that's awesome. We haven't talked about the lignin and the 3D printing. 3D printing is big right now. Everybody's
everybody's on it. So we were talking about these building blocks of you're breaking down the cellulose and lignin into these platforms and these other chemicals.
Yeah.
And what I'm holding in my hand, sorry you guys can't see it.
No, that's okay. I'll take pictures.
But it's a 3D printed object.
Literally that's 3D printed 3D.
It says 3D, yes. and it's made with printing compound that's lignin based.
Yeah.
So again, using building block of wood to create something that was really only possible with petrochemical materials before.
Right. Now it's got a sustainability.
Sustainability aspect of it.
Yeah, that's awesome, and that's the biggest thing, right? The more applications this has,
right,
the more we can,
right.
That's sustainability and helping, sequester carbon better and all those types of things. So I seen recently they're building houses apparently out of 3D printing.
3D printing houses, yeah.
That's pretty fascinating. So they have like some kind of concrete compound, and then So like, do you think that's a potential for this? Who knows? I think it's already a thing. Yeah.
So is it gonna get past the 1 off or the 2?
Right. Is it gonna be 100 or 1,000?
Yeah. Is it gonna become 100? It remains to be seen, but it's already a thing.
Yeah. People's eyes are on it for sure.
That's right. That's right.
Yeah. Well, that's cool. Right. So and your guys' labs. You said you have a few labs in Canada, right?
Yeah, we've got call them research engines.
Right.
We've got one in Vancouver.
Right.
One in Montreal, and we've got a large contingent of people in Quebec City as well.
Nice.
And we've got regional offices across Canada.
Oh, awesome.
Including Alberta.
Oh, that's cool. Yeah, no, it's interesting. Like, I didn't know much about FP Innovations until like today is really my education on what's going on, right? Like just doing research on what your company is about and stuff. So no, it's interesting knowing that it's a nonprofit organization, right?
Yes,
like
it's
so where do you guys get your funding and stuff like that from? It's all free and all kinds of stuff like that, eh?
It's a very unique partnership of industry and governments.
Right.
So industry or private companies are members of FP Innovations.
Gotcha. Okay.
And so are the governments.
Yeah.
And they pay membership fees to be members and participate in the research and innovation within FP Innovations.
Yeah.
And governments support the innovation as well, federal governments and provinces. And so it's a really unique partnership of private and public money.
Yeah.
and because it's done on a not-for-profit basis,
Mm-hmm.
but we're also not for loss. So we are still a business,
Right.
and we still have to make our ends meet.
Of course.
And
You got to eat.
gotta eat.
That's the bottom line. Yeah, you like to do everything for free, right? But like I have that. Never mind. I was going to go off on a tangent.
No. I mean, FP Innovations has somewhere in the neighborhood of 500 employees.
That's awesome.
So
for a nonprofit, that's
it's
wild.
for a not-for-profit. It's a large not-for-profit.
And a Canadian not-for-profit too.
Canadian not-for-profit, yes.
Yeah. So how old's the company?
The company has roots to 1914, I think. I believe.
So it's been around.
So it went through different stages. It was Eastern and Western Forest Product Labs.
Oh yeah.
And then in the late 70s, the organizations or the labs were privatized.
Oh okay.
And there were, there was a Pulp and Paper Institute, there was a Wood Product or Solid Wood Institute, and that was Forest Operations Institute.
Okay.
So it was Ferric, Forintech, and Paprikhan.
Okay.
For those that remember the old days.
Yeah.
And 10 years ago, actually, 2007, those three organizations that were privatized in the 70s came together as FP Innovations.
Awesome.
But the roots of those companies go a long ways. Like I've been with the company for 17 years. I started with Forintech, and the last 10 years I've been with FP Innovations. But it's still the same company.
Yeah, of course. Right,
Yeah.
Right on.
Just bigger.
Yeah.
And we're doing more stuff.
Yeah.
More exciting stuff.
Oh, for sure. Like, yeah, a lot of this stuff I know, like a lot of my colleagues probably have heard of, maybe, but they don't know. So I think this podcast will be like super beneficial to people. I found recently I've had people reaching out from the States that have been listening in too. So it's interesting to see how it's reaching out, and I think it might have like a pretty big impact on the industry. It'll be nice. Yeah, I hope that information gets out there. It might like get people interested in doing this research, right?
Yes,
and learning all this kind of stuff, because it is exciting. Like
it is.
Myself, I'm looking at it going, like, that's pretty neat to sit down every day and kind of think about new ways to improve the forest industry and improve society by making it more sustainable and more environmentally friendly, and sequestering carbon, all that stuff. It's awesome. Yeah, it's cool.
Yeah, I mean, no other countries in the world has 40% of world's certified forests than Canada.
Yeah, it's wild.
And I'm gonna have to be careful, because I'm not trying to aim at anybody, but anybody can decide to make solar collectors or wind turbines or whatever you decide to do.
Right.
But not every country has this resource that we have.
Yeah. No, we're in a privileged position.
We're in a really privileged position.
Yeah.
We were really blessed with these resources, and we've got we've been working with them sustainably for hundreds of years.
Yeah.
And we've got this resource at our disposal, and I think it's a tremendous opportunity that
and responsibility too.
Absolutely, and responsibility.
Yeah.
But many countries would give the world for resources that we have. So it's a pretty fascinating place.
It is fascinating. It makes me wonder what Russia's doing to help. They got most of the forest, right? Yeah. And I'm not sure. Yeah. I don't know anybody that's Russian or those that what they got going over there for forestry. I'm sure they have forestry.
They do, yeah.
They definitely have forestry, but like, I mean, as far as this kind of tech, it's pretty new and inventive, and it's pretty cool stuff. Yeah, we're flying through this, man. We're looking at 48 minutes already.
Yeah,
it's cruising through. Yeah, we haven't even talked about the nanocrystalline or
what you really wanted to talk about.
Well, no. All this stuff is this is all stuff I had written down. The first thing I had written down was wood engineering, fire, acoustics, energy efficiency. So you nailed that without me even having to ask you.
Okay.
So then biomass. Right after that, you're just nailing my questions without even I don't have to say anything.
That's good.
I just wind you up and let you go. So maybe you want to describe kind of. The nanocrystalline, microcrystalline, cellulose, and what's going on there, maybe a little bit.
So again, Canada is the first country in the world that has a commercial scale nanocrystalline cellulose or cellulosic nanocrystals, actually.
Okay. Cellulosic nanocrystals.
Yeah. So CNC.
CNC.
Yeah.
Yeah.
CNC. Okay. And it's it's a fascinating material that just allows us to do so many things.
Yeah.
That I would say that we're still trying to figure out what we can do with this.
Yeah.
I mean, we already have many applications for nanocrystalline cellulose or cellulosic nanocrystals rather. Number of very strategic companies that are working in oil and gas and as well as pulp and paper have invested into that technology and joined the Celluforce partnership.
Okay.
Obviously the applications would be in biocomposites, could be in different finishing materials. I had a piece of plywood that was finished with CNC film, and it's got iridescent properties. It's got
it looks iridescent. It's got it's kind of
iridescent
technicolor.
Yeah. It looks like a butterfly wing.
Yeah, totally. That's perfect description.
Yeah, it looks like a butterfly wing, and also it has pigments that can be extracted from it that are brighter and more vibrant than any other colors that we can actually produce chemically. So it's a fascinating material.
So just to quickly kind of what exactly is it that's making it, or what is it, I guess? Like what makes it different from just cellulose? Is this the same thing or?
So, and I'm just going to get a little bit on a thin ice here.
Okay. That's okay. I apologize.
A cellulose has a crystalline part.
Okay.
And then it's got a part that's, I think it's called amorphous.
Oh, okay.
And so these crystals, these crystalline parts are actually separated.
Oh, okay.
And so they're the pure crystals of cellulose.
I see. And that's what this is.
Right?
Okay.
And that's what this is.
Gotcha.
And so it's got, high strength. It's a very unique platform.
Yeah, that's cool. So is that a pretty new finding? Did we know about this before? Is this something we just recently found out?
I think it's been known for decades.
Yeah. So
but the problem is we could make microscopic quantities of it.
Oh, I see. So only recently has it been.
It's recently actually we've made a breakthrough in terms of actually scaling this up.
Gotcha.
We had a lab scale technology where we could make, first, tiny amounts of it, and then it was kind of a kilo a week, and now we're, I think we're at 1 ton a day or something like that.
Pretty good.
So it's a big scale up.
Yeah.
And I think it may actually be more than 1 ton a day.
That's wild.
So it's
right on. So it's got. So like some of the things I read up on, some of the properties, we can just speak quickly to it, some of the potential for it to be used in, right? Like I saw that it like plastics,
right,
adhesives, cement.
That's correct.
Electronics, medical stuff.
Specialty papers.
Yeah.
Cosmetics.
Yeah.
Because of these colors, you could make it into lipsticks.
Oh,
you could
right.
Make it into cosmetic products that will have colors in them.
That's wild.
Because it's 100% natural.
Yeah. It's
so
just wood fiber.
It's wood fiber.
Yeah, it's
really.
natural. It's not. Nothing has to be done to it to get it that color.
Right.
In, eh? It's just that there's so much of it that it's now you can see the true
right.
color of it. Right. That's cool.
Yeah.
As far as go ahead.
So sorry, I was just gonna say I was mentioning the specialty paper. What I meant was, for example, bioreactive papers. So like food wraps. So imagine having
like a tinfoil or something kind of thing.
Like a tinfoil, you could make clear. You could make clear finishes, clear films out of it. But also papers that would react to certain things. So, for example, you've got a food.
Yeah.
And when it starts growing bacteria, and when there's enough of the bacteria that it's no longer good for human consumption, maybe the paper will change color.
Oh,
so
really?
it'll tell you,
that's insane.
This is no good to eat anymore.
That's
right?
wild.
So things like that.
That's pretty amazing.
Yeah.
I would never have guessed that. That's pretty cool. So that's that's wild. Huh. So I'm just trying to understand that. That sounds so like sci-fi and like it's like Star Trek over here. Yeah, that's pretty cool. And then I remember right before we started the podcast, you were talking a little bit about kind of the medical applications.
Yeah.
Maybe just speak quickly to some of those.
Yeah, it could be in some wound healing
Okay.
applications or blood clotting applications or things like that.
All kinds of things.
All kinds of things.
That's insane.
Yeah.
Plastics and they're just
Yeah.
So the plastics, would that be an additive to the plastics, or could you make plastics out of it?
Well, it would be an additive.
Okay.
You would want the CNC to improve some properties of it.
I see. Okay.
It would be a pretty expensive plastic if you were making it out of
I
CNC.
imagine so. Yeah. So when you see, I don't know if you can speak to this at all. It's kind of a shot in the dark, but you get Dasani bottles, right? And they have on the side of it, they say 50% or 100% renewed plastic from wood fiber or something, right? What are those? What's going on there? No idea.
I have no clue.
Yeah, I don't know either.
Yeah,
I was always looking at that. I'm like, this is plastic. It's a petroleum product. It's made from wood fibers. Like, I have no idea. Well, I have to figure that one out because I don't know. Yeah, it's pretty cool.
Wow.
So is there so anything else that you wanted to in your box there that you think, or any final thoughts kind of that you think,
one of the things that we were talking about here at the beginning before we started recording was use of drones.
Yeah.
Applications for drones.
Yeah.
And it's one of the very growing areas in forestry.
It's pretty exciting.
Which is pretty exciting, and it's 10 years ago it would be a pretty sci-fi thing.
Yeah, people would be looking at you, the corner of their eye, going, everybody.
I don't think so, but it's becoming a really I don't want to say a common thing, but people are not surprised when you say it anymore.
Yeah,
and number of organizations are looking at using it. Some are using it, and I guess you guys are using it as well.
Yeah, Greenlink Forestries. Yeah. We're looking into the applications, right? Yeah. And there's a lot. Like, we're not the only ones. There's lots of, like, you guys are looking into it. And I can't remember what the other company was. I was at one of our AGMs, and they were talking about, they had done extensive research into it, right?
Right.
And like, it's definitely got applications. It's just kind of sorting out where the efficiencies start and stop.
That's right. That's right. And what most companies in the forestry space, including us, are not looking at drones themselves. Right. They're looking at, okay, so what can I do with the images that I can get out of it?
Exactly.
What other sensors I can put on the drone that I can extract information that I need, whether it's LiDAR or whether it's aerial photography or and now when I have all this data, what do I do with it, right?
Yeah.
So how can I actually use the data to predict what my volume of logs is in the forest or in the pile in the log yard, or a pile of chips that's got irregular shape?
Yeah.
How much volume do I have in it? And some of these applications, like planting trees or seeding trees using drones. It will be an interesting time when we're relaxing in the forest and suddenly a drone shows up and just plants a tree right next to you and just flies away because somebody deployed the tree. So it's a pretty neat place.
It's high tech out there.
Yeah, it's pretty high tech. Yes,
won't be the wilderness for very long. That's awesome. Yeah, no, I know the drone technology is something, like myself, I've been fascinated and interested in to see where we can take it, right? And it seems like as a commercial scale, it's still getting to that point. It seems like we're still figuring those boundaries out. And again, as the technology gets better, it'll become more efficient, and we'll be more likely to use it. And it's only going to get better. So,
that's right.
Yeah,
that's right.
Unless we get hit by an asteroid or something, in which case it doesn't matter. But I think that was a pretty informative hour, I guess. That was pretty wild. Yeah, we've gotten to some places I didn't think we would, so that's good. I'm happy you came in. Thanks a lot for coming in.
Well, you're welcome.
Yeah, it's turned out awesome. Yeah, and if there's ever anything else that you want to come in and discuss or whatever, even if it's just a quick half an hour or something, we can. Yeah,
it's never a quick half an hour.
No, it's true. It turns into an hour so fast, right? Like, I listen to a lot of podcasts that are, an hour and a half, 2, 3 hours when I'm driving or whatever, right? And yeah, I totally get it now. How it's so easy to get lost in conversation, just go on forever, right? So, yeah, this is perfect. Thanks a lot for coming in. Appreciate it.
Thanks for having me.
Yeah,
thank you.
Awesome. So, anybody who wants to reach out, have a question for Dalibor or for myself, email at yourforestpodcast@gmail.com. And rate and review it. Tell your friends, recommend it, all that stuff.
And if you're interested for anything more about what FP Innovations does, just go to fpinnovations.ca.
Yep.
And you can find lots of information about exciting stuff that we're working on.
We're so much stuff. Yeah. I was trying to navigate it, trying to get questions for you. And I was like, you know what? I'm just going to sit him down and talk to him. I think he'll go because there's so much on there. I was like, I can't even start to weed through it all. So yeah, no, it's an exciting company doing lots of good stuff. So it's good to know there's companies like FP Innovations out there doing that stuff, not for profit as well. Right. So everybody. So yeah, no, it's awesome. I'm glad you came in. Thanks a lot. Appreciate it. And maybe we'll have you on again.
All right. Thanks so much.
Yeah.
Take care.